Welcome to the Maritime Engineering Category Training and the last few modules required to make you eligible for promotion to able seaman.
So far in Module 7 we discussed density, displacement and buoyancy. Now we're going to use what we learned about the scientific method to make a hypothesis and to test our knowledge to gain a better understanding. Although you will do this yourself as part of Activity 7.7, we will go over the process and explain some of the concepts.
Let's start with your hypothesis. In this test, we will build our boat and we'll test some theories. Previously, we've discussed the mass of an object versus the displacement or volume. We learnt that different materials have differing densities, and this will determine if they float or sink in water. We also learnt that water's density is 1 gram per cubic centimetre, and that if we put a less dense material in water, it will float, and if we put a more dense material in water, it will sink.
We then discussed that if we increase the displacement of the object or its volume, then this decreases its theoretical density. For example, brew peg weighs 50 tonne, but because its volume is full of air, its overall density is less than water and it floats.
In this activity, we're going to take a 15 centimetre square of aluminium foil and we're going to fold it into the shape of a hull. You can use tape to hold the sides together. The hull design's up to you, whether you want a V-bottom or a flat bottom. For the sake of this experiment, we're going to build a flat bottom boat. We're going to add weight to the hull in the form of coins. Pause the video here. I want you to have a think about how many coins your hull will hold and also the placement of those coins. Do you spread them evenly, put them all at one end, put them off to one side? Have a think about how that's going to affect this boat when it goes in the water. So now that you've thought about it, let's start adding weight into our little boat. How close were you with your guess of how many coins you think either your boat or our boat would hold? And also, see how I'm putting the coins evenly distributed around the boat and that the boat is staying quite flat. It's not lurching over to one side or doing anything weird. And this is what we call ballast. By having the weight evenly distributed across the boat, it means the boat doesn't sink. If I was to tip all the weight to one side, the boat would capsize. On brew peg, we also have to adjust ballast. Usually this is with liquid stores such as fuel and water, and this ensures the stability of our boat. When conducting Activity 7.7 yourself, try building some other hulls and see how they affect the number of coins that you can add. Use what you've learned about the scientific method to come up with some theories and test your hypothesis. Have fun with this while you learn.
Good luck with the material.
We'll see you further into the training.